Hey, how's it going, everyone? Welcome to the stream. So today we are going to be playing with OSPF. So I recently deployed OSPF here at home, doing it on my router and my server. And my server is kind of like my lab network router-ish sort of thing at the moment. So basically just messing around with this. Like I think I'm going to have a need at some point for deploying some kind of like small routing protocol, pretty simple sort of thing, just to distribute routes between a couple of different devices and stuff. And it seems to me that OSPF is pretty, good at that. I mean, it's one of the reasons it exists, right? But people have been asking me like, OSPF versus BGP and stuff like that, and it seems like I don't really have the I don't have the expertise here as far as like that answering that question. But I will say that it seems like OSPFv3 is pretty simple, and its job is just to flood routes around and let the routers figure it out, and that's good. So BGP has all kinds of different extensions and all the multi-protocol stuff, and also Go BGP already exists for better or worse. So yeah, this seems like could be something fun. I haven't done a new protocol implementation in a while, so why not play with OSPF, right? So I got some Wireshark captures here. I did a little bit of playing around earlier today. You got a couple of like hello packets between the couple of devices, and they're exchanging their databases and link state, yada yada. Should be a good old time, I imagine. So let's get back to this. So I've got Bird here running on my router as well as my server. I was just playing around a little bit. I'm pretty sure the syntax is not right. Like I was trying to advertise a couple of like routes in here, but I think the networks thing might actually be an OSPF v2 concept. Because if I understand correctly, v2 and v3 v3 generalize things a little bit more. So instead of like networks and subnets, you have just links now, right? I forget exactly. So as far as the whole mechanisms of how this works in the state machine and everything, I am not entirely familiar yet. But if we can start decoding packets, we will be able to start identifying patterns and see what's going on and maybe build some cool visualization stuff. So I think that's a good place to start for today. So let's start a project, right? OSPF3. Hey, welcome. Nice to see you all. Thanks for joining today. Package OSPF3 implements OSPFv3, OSPF for IPv6. Where is the... Hang on a sec. What was the RFC? I forget exactly. Hang on a sec. So, OSPFv3 RFC 5340. 5340. Okay. Make that a lot bigger. We're actually probably going to want this in a different window. Oops. I'll probably want this actually on this display so I can actually read the packet formats. Good place to start, right? OSPF for IPv6 as described in RSC 5340. Sweet. So we have a PCAP. We can start dumping traffic from the links. If we run a binary on my server or my router, we can start dumping the OSPF traffic because I've got the router sending hellos like every 5 seconds, something like that. So I think probably a good place to start would be just opening up a connection and seeing what sort of traffic we can see on the link, identified by the IP protocol number 89, I believe. So OSPF v3 runs directly over IPv6 protocol number 89. So we're going to need the golang.org xnet IPv6 package, actually, so that'll be fun. So, go mod init, and let's see. We're probably going to make some kind of like connection type, like a connection type is capable of sending and receiving OSPF v3 messages. So, type construct. And then we're going to eventually build up some kind of like OSPF snooping command. So, OSPF snoop, right? And go. Okay. Yeah, this should be interesting. Like, routing protocols are an area where I understand like the basics of why they work and everything. Like that, I mean, I understand like the operation and everything, but as far as the intricacies of how this all fits together, this is all new to me. So we're gonna learn together, which should be a lot of fun, right? Did I tweet about? Yeah, I did. Okay. I tweeted about this, and I also posted on Go for Slack. Okay, cool. I see we have people clamoring for the pizza stream. Probably still not going to happen. Apologies. So what's interesting is actually my neighbor discovery project. I have some of these similar patterns as far as like building a connection type and doing the IPv6 socket. But I think I'm going to probably try brand new. So XNet IPv6. You're not thinking about type hierarchies for starting a new Go app. This is a new app. This is the power of Go, boys. Yeah, you don't need to think about type hierarchies. Yeah, so I want to create a connection with a certain protocol number. I forget exactly how you do that. I want to say it's the packetcon type. PathMTU, packetcon. This is going to be raw IPv6. Yeah. Oh, advertising OSPF hello. How interesting. There is actually a thing you can use here to apparently send an OSPFv3 hello packet. How strange, huh? Well, that's a pretty convenient example for us. But yeah, this is what I was looking for. So IP689. Okay. And then we join the group of the all SPF routers. Wow, this is awfully convenient. All right, stream over. Thanks everybody for joining. We're done with the stream today. Yeah, we're gonna steal some of this. We're not actually gonna send hellos. We're gonna listen though. But so yeah, net listen packet, net IPv6. Did that work? Did that work? There we go. Now it's downloaded. Yeah, so OSPF v3 IP6 socket. We're going to bind to the unspecified address. I would think we would bind to the link local address of an interface, but... So probably the way we're going to do this is... Yeah, so func new con, or listen, dial. What did I call this? I think I called this dial... What do you call it? You need the stream until at least the AOC stream. Yeah, that's gonna be interesting. Ooh, excuse me. I saw AOC is streaming tonight at 8:30 to explain some of the stuff that's going on, which is pretty interesting. Yeah, I call this dial. Okay, we'll probably do that too. So dial on the specified interface, right? So func dial on a given net interface produces a con and an error. This ought to be a good old time. So yeah, we're gonna do roughly these things. Roughly. So we'll just steal that. We can probably... I was reading the RFC for a little bit earlier and trying to understand how this all fits together, and there's stuff like the traffic class and stuff like that. Like, in theory, you can set a higher traffic class, so if the router actually cares about that, it will recognize this as like a higher priority sort of thing. So, by the way, that link will 404 for now. I haven't created the repo yet, but that's what we're doing. So we're gonna listen for OSPF on, I think we're gonna log into my server probably. So the server is gonna be on the lab VLAN, which is gonna be the bridge. So yes, this will be the bridge. Okay. So connection error. So OSPF3 dial on. Hey, what's up, JB Pratt? 10D stream once you make it big with GME. That's not gonna happen. I am in on GME. You know, stonks, but I failed to get bridge 0. We're gonna dial on bridge 0. Open OSPF v3 connection. On. Defer, C, close. So this is where we do the all SPF routers, which is this FFO25. Yeah, so we can do that. That's going to be joining on the link local. Yeah, so we actually have to specify P join group, IPv6 packet con. I could have sworn you had to specify the, for the link local address, I could have sworn you had to specify the zone as well, actually. But maybe the zone can be inferred based on the connection. Anyway, so return nil error, protocol number 89, bind to an unspecified address. We actually want to bind on a certain connection, though. So, is this... Can you bind to unspecified... I'm going to open up my NDP project because I'm curious now. Code, source, github.com, mdlayer, ndp. Because you need to be able to bind to just the specific interface. How do I do that? Yeah, I think that I bind specifically to the zone identifier. So I'm pretty sure I actually want this to be plus interface name. I believe that is correct. We'll see though. We'll find out. Yeah, so we're gonna have a good old time. I don't really know what I'm doing. I mean, I have an idea. Like, we're gonna snoop some traffic or we're gonna decode some packets. But as far as things like the OSPF state machine and such, I have no idea. So that's gonna be definitely an interesting thing. Do you have your carpal tunnel gloves help you get better? Yeah, I do actually. I'm actually not like sword stage. Just my hands are cold. So these are for warmth. But yeah, I appreciate it. This is gonna be the IPv6 packet connection for raw IPv6 connectivity type stuff. Yeah, and then we've already got the interface information. So yeah, we need to join the SPF routers group. Is there not a constant for that? Actually, I could have sworn. Is there a constant for all SPF routers? Let's see here. Variables. There are no. Oh. Okay. Maybe not. Yes, so this is actually exactly what we need. So we can just go ahead and use that. Cool. So we're going to join the multicast group on the interface, which is the all SPF routers. We'll go ahead and factor this out. So all SPF routers. The net IP address with a zone. See, yeah, I thought you needed the zone, but maybe you don't. Maybe this is enough. So does this add the zone? Hang on. Group. 2IP16 set group on the connection. Okay, so maybe there's something in here that's handling this for you. Group request. Okay, so it does attach the interface index for you automatically. Okay. I assumed, I wondered if that was the case, but I didn't know for sure. Yes, this is going to attach the interface index. Actually, I suppose I could do that too, right? So I could do format sprintf. Because if you bind to the index is more unique. Index. Oh, it's already, never mind. Index. Okay. That's wrong. That's right. The interface index. Right. Okay, so we've got our IPv6 packet connection. We are joining the all SPF routers. I think we also want to join the... If we're going to snoop on the traffic, we probably want to join the designated routers group too. I forget exactly. So FFO2::5. Where's the RFC? I've got way too many tabs open. What are all these projects? Oh, my stream stuff, don't need that. My NICS configuration, probably don't need that. Wireshark, I do need that. Zoom can go away. Why do I still have Zoom open? Hang on one sec. Go away. How many Chrome windows do I have here? Okay, I guess that makes sense. Anyway, bring that back. Yeah, so we're looking for FFO2::5. Yeah, this is the all SPF routers, and then there is the certain OSPF protocol packets. So we probably want to join all designated routers too. If we're just going to snoop on all the traffic, so all D routers equals all of this plus the 6. FFO2::6. That's all link local multicast, so cool. So we'll go ahead and join both 4G within net IP adder of all SPF routers, then all designated routers. We will join the groups. What am I doing? Return, no. It's kind of funny sometimes because like I've been writing Go for long enough that I start just typing certain things without really thinking about it, you know? The address of G. I guess I could just make these pointers. Simplify my life a little bit. Defer leaving the group. Yeah, we're going to want to leave the groups as well. So before we close the connection, we leave the groups. So that way other devices can see and things like switches won't try to forward us like OSPF traffic. So leave group. We're going to need to store the interface as well. So IFI net interface. So you have an OSPF con here that is built on top of the IPv6 packet connection and also stores the interface you used to establish it. So now you can actually leave the group as well. This is going to be C leave group, C con leave group, and then C interface. Yep. Did you buy one of those mini kegs? No. Oh man. So Bell's here in Kalamazoo. Op Slam mini keg 2021. Yeah. So Bell's releases Hop Slam in mini kegs. This is a 5-liter mini keg of Hop Slam, and I can tell you from experience that you really don't need much more than maybe 24 ounces of Hop Slam is probably where you should stop, and 5 liters is an awful lot. So yeah, would not recommend. I've had some experience with Hop Slam in the past, so I'll leave it at that. This is the story for when you talk to me off stream. That's dangerous, 10%. Yeah, it's no joke. It's a good beer, but it is dangerous for sure. Yeah, now we're gonna start snooping for OSPF traffic, I think. So let's see here. So con probably some kind of like reading function, but we're gonna cheat for now. Just joining now. Always happy to see the Twitch notification. Well, hey, thank you for having the notification on. Yeah, I'm happy to be here. It's kind of funny because I'm actually much more awake and like ready to go than I was I have been like previous days this week. So I'm like, you know what? I should stream today. And I think I'll probably stream on Saturday as well. But when I got this little OSPF setup labbed up, I'm like, okay, well, I can start decoding packets and just see what's going on. And, maybe people would like that, right? So we'll have a good time. Cold brew. I don't have cold brew right now, but I could. I'm actually feeling pretty good without it. I had some green tea at like 1 o'clock and I've been actually feeling pretty good. So I think I'll probably skip caffeine for the rest of the day, even though I want it, My problem is I try and go to bed at like 10:30. I know. Because I really do a lot better if I have 8 or 9 hours of sleep. So, this is not going to return for now because we're going to need to do some packet decoding. So, make probably the size of the interface MTU is the maximum. That would still be even too big, but that's fine. So, we'll make that, and then we need to start reading from the connection. So, that would be probably something like this. So, C packet con. Check some. Go please. Hello? Oh, wait, what? What was that? Hang on. So the packet con has, oh, weird. I think go please might be doing some weird stuff on me. The one I'm looking for is join group. We already got that. I want read from. So bytes control message. That's right. So you get end control message source error. Message source error. So if we do this, we should start seeing some stuff flowing in, which would be pretty cool. So for the time being, we're just going to return the error. This is going to block otherwise, and then we're just going to dump out the rest of the stuff we see. So dump the control message, the source, and then the bytes up through N. And this should, in theory, start giving us OSPFv3 traffic because we're looking at the proper IP protocol number on the specified interface. So I believe this will work, and we can close the rest of these files as well. Close the doc file. Okay, so this is really silly, but if error := C read. It's going to be something like C read from. It's going to, read one packet at a time. Fails to read. This will block. And that's that. So let's see if we can get something going here. So does this build? It does. That's right. I want to run it on my server because my server is participating in an OSPF topology, OSPF peering, OSPF neighbor. I don't know the terms actually. Consider putting B outside the loop for within read. Yeah, I will. Yeah, it's just a temporary thing right now. Effectively, what this is going to do, this is going to do like a one-shot read. I guess I could just make it that way right now, right? I could just do this instead. Yeah, it's gonna be more like this. So I guess it doesn't hurt for me just to clean it up a little bit. Anyway, we got the server up here, which is participating in OSPF. We got this down here, so we're going to build, and we need to disable CGO because it's NixOS, SCP, OSPF, Snoop. Over to the good old server. OSPF, Snoop. Okay. Socket not, that's right. So we're trying to open a privileged socket, cannot bind to the requested address. So we tried to bind to unspecified on index 5, and that didn't work. I could have sworn there was something in here to specify just a single interface. Source specific. I mean, I guess it doesn't really matter, but... Hey, Stupak, welcome. Thank you for the follow. I appreciate that. I could have sworn there was a way in here to bind to just a single interface. Home lab PogChamp. Hell yeah. Yeah, I got a little OSPF lab going right now, so we're gonna have fun with that. BPF filters, checksum, control message, hop limit. This are all the IP parameters, and those are things we're gonna want to do, but traffic class, that is something we're gonna want to set as well. Yeah, this doesn't seem... I guess if we bind to unspecified, that's okay, because we're only going to see traffic on the groups that we're joined, which is going to be the all SPF routers, which we're only joined to on this interface. So that should be fine, I guess. Let's give it another go, right? So I should start seeing hellos within... Hey, there we go. We are getting OSPF traffic. So the control message is nil. But yeah, we're seeing things coming from the link local address associated with bridge 0. So you see terminals of the home lab, only you see photos of the home lab. I don't know if I have any good photos. It's kind of a mess right now. I mean, my home lab is just a desktop computer over... It's like a desktop computer sitting in the corner. Do I have any good photos? I don't think so. I should do a write-up about what I do with that stuff. I've done one for like my desk and stuff like that. This is a lot more impressive setup anyway, but yeah. So we're seeing here, actually the first octet, I know O3, that means OSPFv3, so we're actually seeing OSPF messages. Pretty cool. I like it. I like it a lot. We are at the point now where we need to... My home lab journey started like many others with I want to run Plex. Yeah, totally. Yeah, this is my home lab machine right here. So sudo zpool or zfs list. Yeah, so I've got a ZFS set up, and all that. And I'm running Plex, NixOS, NixOS, Plex, Unify Controller, NFS Server. Actually, I have my home lab repo, which I've showed off a few times, but github.com, mdlayer, home lab. Yes, ZFS on Linux. Yep, works just fine, actually. So yeah, these are all my configs and stuff, and if you go specifically to the NixOS directory, you can check out all of that stuff as well. We'll probably get back to Wireshark, but I think for now we can go full screen here. Hopslam minikeg. Yeah, these are all my configs and stuff, so you can actually check out like all the stuff I've got running and how it's configured. Pretty cool. Okay, so we are listening specifically for OSPF traffic. I want to get access to I want to get the control message as well. You definitely do not have 5 views enterprise servers. Yeah. That's so funny because like I've seen people who do that, and for me, I just have a I can just run, what is it? Screen fetch, right? Really? Fetch. Really? I could have sworn I had or no, NeoFetch is what it is. Yeah. So this is my server. So NixOS, AMD, Ryzen 7 2700, 32 gigs of RAM, 4 8TB WD REDs. So, yep, simple enough, you know. And if I run that over here, yeah, my desktop, Ubuntu 2004, Ryzen 9 3900X, yeah, good stuff. By the way, yesterday you were watching my YouTube stream, and even though some parts you speak really fast, Google's auto-generated subs are like perfectly matches your talk, like 99.99. Nice. So what's funny is my presentation / in public voice is not the same as like my regular speech in general. Like I tend to, if I'm like talking to friends or whatever, I kind of, you know, a little bit like less enthusiastic like this. But when I'm presenting, I tend to enunciate a lot more and really try to amp it up, and maybe that helps, you know. So that's pretty funny. Yeah, so we are snooping. I don't have that link. I do have this. Yeah, so I post all of my stream recordings on YouTube, so if you're interested, go check them out. So I want to get the control message. How do I do that? So C set control message. Yeah. You don't have a YouTube section, link in your about section, FYI. Gotcha. Yeah, you know, I haven't touched my I haven't touched my about section in quite a while. I should probably take a look and revamp things a little bit, but thanks for the heads up. He doesn't actually have friends to talk to. Don't let him fool you. Yeah, that's true. Quite true. Motherfucker. We got some nice real life friends in here. ICMP filter. No, we're not doing ICMP. Hop limit, deadline. So I want to get a hold of the control flags. There we go. So I want to see the traffic class interface. I guess we don't really care. Traffic class hop limit source dest interface path MTU. Ooh, path MTU is an interesting one. I guess that there's something in OSPF about path MTU depending on the number of like LSAs, so link state attributes, I believe they're called, something like that. Depending on the number of like basically items like routes and stuff you're carrying in your OSPF messages, you might have to break it up. So you can use things like the path MTU to figure out how to batch. So that's good to know for later. But I just want to take a look at these really quick. So let's set some flags. So IPv6 flag dest, IPv6 flag source, the interface, and then IPv6 flag. How about the? Let's just do all of them. Why not? Hop limit. Dest source interface MTU hop limit. What was the last one? Did we get them all? We might have. Path MTU. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. I'm staring at this and I'm missing one. Hop limit. I just did that. Dest source interface path MTU source traffic class. God, I'm so silly. Anyway, on. True. Do it. Return nil. Error. You believe one benefit of working remote from your hometown is keeping close ties with lifelong friends? Yeah, totally. I'm actually, I don't live in my hometown, but I live in my college town. And even though lots of folks have moved away, I'm still in good touch with people, which is great. So Kalamazoo is a cool place. Oh, an OSPFv3 MTU value is carried in the database description and must match on both sides of the peering. Okay, cool. Yeah, I was curious. Yeah, I guess that would make sense, right? So later on, when we're dealing with things like, potentially the OSPF like state machine and sending these LSAs and stuff, we're gonna have to figure out how to batch, and we could always like split it up based on the MTU, assuming that both sides have the same MTU. So it's good to know. If error, what does this give us now? This is gonna give us more IP level information, right? So I want to see what exactly pops in when I get a hello. Okay, so the source address, the destination. Destination is all SPF routers. The source is, yeah, it tells you where it came from. We've already got that, actually, so we don't care about the source. The hop limit is 1. Yeah, so the hop limit, I think, is also important because that means that this certain messages should not be forwarded beyond... Actually, is that always the case? Like, isn't an area just supposed to be essentially like a link local domain in OSPFv3? I read about this a little bit earlier. And then the traffic class, that's something we're going to want to check as well, because that actually, you're supposed to set the proper priority. The MTU is not set, meaning the path MTU. So, I suppose we're probably going to want to return destination source interface, path MTU, next hop. All messages apart from virtual links or link local. Yeah, gotcha. Okay, so that would make sense that you would see a hop limit of 1. Okay. As far as the virtual links thing, I'm gonna have to do a little bit more reading. I looked through things earlier, but today I think we're just gonna mostly focus on like the raw packets versus like trying to interpret meaning from them. But it sounds like you know what you're doing, so I will definitely be hitting you up with questions. Source desk. Can you break them up like this, right? We set them all. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Yes, we did. Okay. So we'll turn on the control flags. Let's see here. This can actually be constant, which is nice. And then we're going to return, effectively, an OSPF message, the IP control message that came with it, and then the This is going to be roughly this. It's like a message interface. This is like the same pattern my NDP library uses. The IPv6 control message. And then an error. And it's worth noting this API is going to allocate, but I don't think OSPF needs crazy high performance. And that being said, we can always add a non-allocating version later on if we need to. So, type message is going to be an interface type of some sort. And the message is going to, much like the NDP library, be something like the OSPF hello. So actually, we can start decoding this hello. I think that's probably a good place to start. We'll do the OSPF header. So for example, version 3. And then followed by the contents of the hello message. So, nil error. Yeah, this would be nil control message nil. So I guess the first thing we could do is make a type for messages that we don't recognize. This is something I've done in my NDP library in the past where if we have a message we don't implement, but I don't think there's that many messages. So I guess let's just look at hello and see what the packet format is like. Actually, I've got it up here, don't I? This is the struggle with not having all three of my monitors, since normally I would have this open elsewhere. Right. So the appendix, is that where we are? Yeah. Options field, I know there's some flags and stuff, we'll get there. Okay, the header. So the version number, type, packet length, router ID, area ID, checksum. And 0, this must be reserved, so what do we got here? 16 bytes? Yeah, 16-byte header. Easy enough. Nothing even on a weird boundary, so we can do all easy operations here. So, let's see here. So type, header, struct, version, int, type. Well, I guess this could be uint8, couldn't it? Type uint8, length, uint16. Router ID, uint32. I know it's really strange. I know OSPF, like, the router ID is just a 32-bit number, right? But people tend to use, like, the IPv4 address, which is an interesting thing. So maybe we'll make, like, a type that allows you to do that more easily or something. Area ID is uint32. I'm just actually assuming I should probably look, but packet length in bytes. Yeah, uint32. So types 1, 2, 3, 4, 5. Hello, database description. Type hello. Let's see here. So type packets type int. Hello packets type equals 1. Database description. Packet type equals 2. Link state request packet type equals 3. Stat request. Link state update packet type equals 4, and then link state acknowledgement packet type equals 5. Okay. Packet type. And actually, we can make this a uint8, so it fits nicely into there. The router ID, the area ID. I've only got area 0, and I've got a couple different router IDs, which are just the v4 addresses right now. The checksum. Checksum is the IP header checksum, isn't it? At least I thought it was. The standard checksum for calculation for IPv6 applications. So we might verify that. Probably now. For now, we're not going to. We're going to cheat. But checksum uint16. The instance ID uint8, and then a reserve field. So cool. So every message is going to have this header. So the first thing we do when we read a message is allocate a header and then begin filling it out with the bytes. So the size of a header is going to be 16 bytes. Const size of header equals 16. I guess I could do like header len. So if b up through n, or if n is less than 16, there's not enough, or if n is less than the header length, there's not enough information here for an OSPF header. So we probably return an error because we're looking at the specific IP protocol number, so this message doesn't make sense. So nil errors.new OSPF3. Not enough bytes for OSPFv3 header. And now we start unpacking it, so easy enough. Can actually just do this. So version, the first byte. I actually, I was thinking a little bit ago, it would be kind of nice to make like a buffer type, so I don't have to do all this offset math manually. This is something I end up doing a lot, is basically writing all these offsets by hand, and it's not that big of a deal, but I wonder if I can make it nicer. So I could do like, for example, B, uint8, B, uint16, stuff like that. Like kind of basically the iterator pattern I've been talking about a lot recently. We could effectively do that, but for the time being, we'll do this. So type is going to be the packet type of B1, also uint8. Length is going to be the packet length. I guess we'll stick with what the RFC says, right? So packet length. I generally will try and follow the RFC naming conventions where possible. So binary, big endian, uint16, B2 through 4, right? And then we have the router ID, which is going to be binary, big endian, uint32, B4 through 8. The area is the same thing. Add another 4. 8 through 12. The checksum. 12 through 14. And then we have the instance ID, which is B at 15. 15? No. No, it would be B at 14 because 15 is the reserve byte. So they should be set to 0 and they must be ignored. Okay, so we'll ignore B15 is reserved. Right. So now we got us a header. So we'll go ahead and dump that too, right? And go back to our test program and run it again. Assignment mismatch. Oh, that's right. So message, control message error. So we don't return a message yet. We do return the control message. So let's just dump. And then the source as well. Actually, we're going to need the source address. But I guess that's contained within the control message. So we don't really need it. We don't really need to return it, I guess. Because this will tell you the IP address that sent it. Although this is a net address, this is slightly different because this is going to be the address with the zone identifier attached. So it'll probably be convenient. So we'll probably do this. So net adder, maybe net IP adder specifically. Oh, it had to do a type assertion, one I? I guess it's okay. It's fine. Nil, nil, nil. The source type asserted to a net IP address because we know this has to be an IP header. This doesn't it? Yeah. Yeah? I know OSPFv3 is like protocol, like it can be run over, it runs over v6 though. Yeah, so it always runs over v6, but it can encapsulate v4 or v6 data, right? Yeah. This will be called read from now. Source error. And for now, we will underscore the message because we're not actually looking at it yet. Because we don't have any message types yet. We're going to have to implement them. So no method read from. Yes, it does. Did I not save? Okay, there we go. Okay, got to run this with sudo every single time, which is a bit of a hassle, but I guess I could just, there we go. Okay, so we're seeing version 3, type 1, which is hello, packet length of 40. The router ID is, yeah, that'd actually be an IP address, right? I feel like I should probably make the router ID like a type, so you can like, I mean, I could interpret that as a what do you call it? I could interpret that as an IPv4 address. Area 0, checksum, that works. Instance 0. Actually, do I see my own hellos here too? Because I'm actually running OSPF on both the router and the server, so I wonder if the server would send its own hellos to bridge 0, bridge 0. We're getting a control message twice. I think I need to not duplicate that. Oh, that's right. I can hide this now. I can remove that. One more time. Yeah, okay. So we are seeing, actually, this is where we can start bringing in another good old friend. The stringer utility is quite useful. So how do I use, let's see here, source github.com, md layer eth tool. I can never remember the exact command, but we're going to use stringer because that's also very useful for us. There we go. Put this in the docs file. So packet type. Please generate strings for me. I would appreciate that. It'd be nice. And then we code. Code? No. VS Code? No. What am I doing? Go generate. And now we'll actually get nicer. We'll get like a hello message here, which would be cool. So, oh, actually update. Yeah, that's right. So we're gonna have different types, of course. Hello. Yeah, cool. Is the, let's see here. If OSPF always runs over port or protocol number 89, does OSPFv2 also have a 16-byte header? I guess I should find out. We're specifically only targeting v3 just to keep things more in scope, but OSPFv2 header. OSPF version 2. What have we done with stringer? So the stringer utility, I put a dot comment here, go generate stringer. So I say every time I run go generate, do stringer type packet type and put the output in string.go. This generates a very efficient string implementation. If it's too much, I can read some docs. Yeah, no big deal. So the stringer utility generates a very efficient string of this thing. So that, for example, you see hello here, like symbolically instead of just the number. And it does this in just a very tricky way versus like writing a standard switch. Excuse me. So it generates good code. So if this is something you have like constants you want to assign names to, the stringer utility is a good way to do it. Anyway, so the OSPF v2 header, LSA header. Oh my goodness. Header. LSA header. OSPF packet header. There we go. A 24-byte header. Because it's got the authentication stuff. Right. Yeah, so we're only looking at 16 bytes, so we can actually just skip anything that's other OSPF versions. So I guess in that case, we could potentially just loop in here and then break once we read a single OSPF v3 message. I mean, I think that's probably the reasonable thing to do. So allocate, and then loop. So if the header, so if b0 not equals 3, then we continue because we only care about OSPF version 3. Is this where the routing is happening? What's up, Dominic? Maybe. We're snooping some traffic right now, so yeah. Ignore any other OSPF versions. Because this package specifically only does v3. Because that's all I care about. I don't know how hard it would be to make it do both. Like, possibly, I'm sure there are ways, but meh. I don't really care that much either. Right. So this is where we start decoding the different message types. So we'll create like a hello and such. So the hello message for OSPF v3 is over here. Hello packets, type 1, periodically on all interfaces in order to establish and maintain neighbor relationships. Hellos are multicast on links having a multicast or broadcast capability, enabling dynamic discovery of neighboring routers. Yes, so this is kind of where the magic happens. So that's a fair amount of data. Oh, it's got the header attached as well. Okay, I was gonna say that seems like a lot, but it's got the header pre-attached. So interface IDs, all of this, and then ... Does that indicate there's options here? So after the neighbor ID, is that it? Why would it have this? Oh, is this where the LS? Is this where like the attributes come in, the LSAs or whatever? Maybe there might be like options associated with this or something. Yeah. Oh, there's options right here. Well, after the header, we're gonna have the hello packet. Type hello packet, hello struct. Actually, I don't think this is gonna work because I've got hello now, so I think it's ambiguous. So pretty sure that won't compile. Yeah. Damn. Do I call it the hello packet or do I just call it hello? I mean, I guess hello packet is fine, but it's not as nice. I guess I'd rather keep the nicer names for these instead of like the constants, but the hello packet will have an embedded header. Embedded? Do I want to embed this? No. Don't want to embed it. You'll have the header accessible if you care about it, but we're also going to have all of the information from the hello itself, which is all of this. So, starting with the interface ID, which is uint32, hello type. But if I call this like hello type, oh, you mean like for the constant? Yeah, I'll probably do that. I'll probably end up doing that. Or like type hello, type database description. I'll probably end up doing that. But we'll see. Hey, Simple, thank you for the follow. Welcome to the stream. Oh, are there any plans for out of context? Are there any planned special case for the IO util deprecation static check? Not sure yet. It'll be you're worried it'll be too noisy for people. Yeah, I think it'll be probably a couple Go releases. Like, you know, most people are using things like, you know, 117, 118. That might be a good idea, but I think for now it's probably reasonable to leave it alone, you know. RTR priority. Yeah, I'm not gonna write that. I'm gonna write out router priority. uint8 options is a uint24, so options uint32. That's fun. Hello interval is a uint16, which is probably the number of seconds. So this is where I start deviating a little bit. I'll probably put a time duration in here instead, but it will be capped at the value of a uint16. It's worth noting that the IOUtil package isn't using the deprecated dot comment, otherwise we'd be automatically marking it as deprecated. Right. Right, yeah, that dot comment you can use to deprecate some of your APIs. I've actually done that in the past as well. It's pretty nice having like a standard convention for doing that, you know. This is where we're gonna start using nicer types: router, dead, interval, designated router ID, backup, designated router ID, 32, and then the neighbor ID. I think we're gonna make like an ID type in here or something for all these different identifiers and make it so that you can do things like the v4 format or uint32 or whatever else. I think that will be nice. So, hey, Sergeant Squigs, thank you so much for the Twitch Prime sub. I appreciate that. Yeah, that's awesome. I really do appreciate that. Thanks so much. I'm glad you were choosing to spend your Jeff Bezos free money with me. Thanks. You got it, dude. Yeah, nice. Right. So the type field is going to determine what we do next. So switch on the header type. And for now, we ignore everything we don't recognize. So case hello. Then we create a rm message. The message is going to be a hello. And then we're going to unmarshal into the hello. If error colon equals m unmarshal binary, something like this. B up through n. Actually, we'll skip past the header, so B up through n. So the size of the header, so size of, not size, Header len onward up until n. Yeah. Turn nil 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 error. And then we can finally return the message. So the header gets put inside the hello message. So we're looking at something like this. Binary unmarshaller. Actually. Right? No, it's encoding dot binary unmarshaller, I think is the, yeah, that's what it is. So then we start writing the decoding method. So h hello packet. That's right. Unmarshal binary. And this is going to be a fixed number of bytes as well, right? It looks to me anyway. So we need 4, 8, 12, 16, 20. This is 20 bytes exactly. So 16 plus 20, 30. Hang on. 16 bytes plus 20. This is a 40. So there's something at the end of this. Is that what I'm missing so far? Can a hello contain... Yeah, I think these dot dot dots, I think we're missing something so far. LSAs? Links to acknowledgement, LSA header format. Yeah, we're gonna need to... We're gonna get into this. It looks like this is like the TLV sort of stuff. Actually, shoot, we got the Wireshark captures, so why not look at those, right? So within these hellos, we are seeing options. Backup designated router is the last field. Oh, really? What about the neighbor ID? Right? OSPF hello. OSPF header, reserved bytes. Excuse me. Backup designated router is not the last field. There's the neighbor ID as well. What am I missing here? Let's see. Shouldn't have scrolled. Oh, the first OSPF hello would not have the neighbor ID, I think. Interesting. So the router IDs of each router within the network with neighbor state 1 way or greater. Interesting. I find it strange that it would just not have it set to like 0 or some magic number. So let's see here. So if we do the below ones, active neighbor. Aha. Yes, you are correct. How strange. I wouldn't expect the protocol to modify the... Oops, sorry. I would not expect the protocol to, like, optionally add or not add this active neighbor field. That's, interesting. Okay. That's good to know. I guess it's optional, so this is going to be a pointer, I guess, which is strange, but we can do that. You only include it once you've seen a hello. Okay. Oh, hey, Robco and Boss Khan, thank you for the follows as well. I appreciate that. My apologies. Sergeant Squigs, thank you for the follow as well. I missed that because of your sub, so I need to catch up a little bit. Thank you all. This is called the hello scene message. Interesting. Okay. So it's just very slightly different. So I guess I could add like a field here or something. Nice cup of tea. Thank you for the follow as well. Yeah, I could always do something like this. I could do like, hello packet neighbor type method or neighbor ID method to see if you actually established a, if your hello has been seen by elsewhere. We'll see. We'll make this API good and ergonomic. That'll be good. That'll be a focus. So we're expecting either a minimum of 40 bytes. No, not 40 bytes. We're expecting a minimum of... right, so after the interface ID, so 1, 2, 3, 4, 5. So we're expecting 16 or 20 bytes. If it's less than 16, it can't possibly be valid. So error F, OSPF3. Not enough bytes for hello. I guess this could be like IO unexpected EOF or something. We'll get there. With the new Go error wrapping stuff, we can make the errors a little nicer, which would be good. Wow, getting a whole bunch of let's see here. Uh-oh. Network engineer friends are like, why are you writing your own OSPF implementation? Because I can, damn it. I think probably, I'll be running Bird for a while, and we will see what sorts of needs I actually have. But, this is for fun, right? So, I have a good time doing this sort of thing. Oh my goodness. Messages. Twitch chat, Discord channels, and subreddits. This is the New World Order. Yeah, exactly. So the router priority. Did I already get interface ID? No, I did not. Interface ID is first. Interface ID equals. So we're going to overwrite the entire contents. Actually, no, we don't want to do that because we already attached the header. So h interface ID equals binary big endian uint32 of B0 through 4. So the first 4 bytes. I know you can omit this, but when you're doing like a big block of these, I like to kind of have it. The router priority is going to be a uint8, which lives at index 4. Yeah. 0, 1, 2, 3, 4. Yes. And then the options, bit shifts. Bit shifts, fun. Binary, big endian uint32. B4 through 8 shifted down? No. Yes. Shifted down by 8. Right? Because this is going to be a uint24. So we interpret the entire value. Oh, no, we need to mask off the top, don't we? Yeah, we don't want to shift down by 8. We want to mask off the top. So, and 0x. Like so. Yep. Hello interval. So h hello interval equals binary big endian uint16 of the B at, oh great, unknown is calling you via, yeah. Man, Hangouts keeps messing me up, He can write an OSPF implementation, make 27 people watch it. Haters, now what? Yeah, exactly. Yeah, we're having fun here. This is one of the ways I like to learn a protocol is by playing with it. Basically like start writing out packets and then start like sending and receiving things in the wire and just see what happens, right? Like I think this is just an interesting sort of thing to do. So I have a good time doing it. 8 through 10. You're following an OS from scratch for ARM Cortex-M who averages 300 viewers. Twitch is indeed a different place. Wow. Could you please send me a link to that? I'd be very curious to check out that channel. Please and thanks. It sounds cool. I would love to build like a hobby operating system. That's definitely not one of my pipe dream projects, but it's going to be a while, if ever, I think I got the math wrong here, didn't I? Hang on. Yeah, we skipped 4 bytes. Options 4 through... Oh, hang on. 0 through 4, interface ID. Okay. Byte 5, then options. Yeah, so 16 or 20. So we're already up through the router dead interval. Did I do my math wrong? I think I might have. This should be 20 or 24 bytes. So 4, 8, 12, 16, 20, 24. Yes, this needs to be at least 20 bytes. And then if it's 24, we can actually parse the neighbor ID as well. So the designated router ID is going to be the uint32 of, let's see here, so 12 through 16. The backup is going to be B16 through 20. Strawberry Hacker, student from Norway. We finished 2 kernels so far in like the last year. Now he's writing a multi-kernel, so each core is writing its own kernel. Interesting. Operating on its own kernel. That's wild. So twitch.tv/strawberry hacker, huh? Cool. That sounds fascinating. I will give them a follow and I will check it out. So, thanks for letting me know. Yeah, I definitely want to keep finding more people to raid and to host and raid and stuff too. You know, we've got large data bank, we've got Mdemsky, we've got Anthony writes code. But yeah, if there are more cool programming folks out there, I would love to check out their streams and also kind of help build this community. So let's do that. Len of B is greater than or equal to 24, then we can also set the neighbor ID, which is going to be the binary big endian of B 20 through 24, right? Yeah, I think this is correct. So we got a hello packet, we unmarshal it. What's going on? No, I did not want to do that actually. Why is this not compiling? Hang on. Cannot use it. Does not implement message. Oh, it's got a pointer receiver. Yeah. Fair enough. Okay. Yeah. So we are only parsing hellos. So let's parse some hellos. So we'll dump the source, the control message, and then the message itself, right? So we should now be able to see any OSPF hellos going on the network. Hey, already, huh? Con line 98. Wow. What did I forget? Dereferencing a nil point. Yeah, I guess that technically would be a nil pointer, huh? So, can you do this? No. So I'd have to store it to a local variable. Yeah. Yeah. Silly little thing. We don't have optional types in Go. There we go. OSPF hello. Interface ID 9, router priority 1, options 275. It's a bit mask, I'm sure. Or actually, no, it's I guess it is a bit mask, but it's bit flags. So hello, 5 seconds, router dead 20, designated router ID, backup designated ID, neighbor ID. Cool. So that worked. So we are at the point, actually, where I think that I want to make some sense out of these router IDs. So I think we're going to make a type here, probably. So where is the... Let's see here. So people usually use IPv4 addresses, right, for these? Like, I feel like we should, yeah, set to 0000, yeah. Even though this is a uint32, I feel like we should probably stick to the IPv4 string format. It's, like, silly, but... ...32-bit number, let's see here... Cannot be set to the IPv6 address. This is commonly done for v4. So some local administrative procedure. Yeah, but it seems like the people really like this string format with the zeros, huh? So I guess I should probably just do that. So it probably makes sense to type router ID uint32, and then we add a string method for that. So string. So when you stringify this, you get the IPv4 address representation. So I need to interpret each octet. I guess I could just do this, right? So we can just make it as an array, and then instead of unpacking it as a uint32, we just work with the array. Arrays are kind of weird. I mean, the thing is here is this will allow us to not deal with the endianness bullshit. That's always a good reason to fix these things. Let's see. Yeah, this is not gonna... What? How did that compile? That doesn't make sense. Oh, I'm not using it. Ah, that's why. I was like, that doesn't make any sense why that would compile. Yeah, right. So now the problem is I need to... The old router ID gets unpacked here. We need to... This is currently a slice. We need to turn it into an array. Wasn't there a proposal recently to like turn parts of like a slice into a... turn a slice into an array pointer or something. And then you can dereference the array pointer. That would be nice. I think that might be coming fairly soon. I forget exactly, so... sorry, Wireshark. Where is this one? So... didn't Daniel... Hang on a sec. Twitter.com MV Dan. Really? Oh, that's right. He's got the... Yeah, that stinks. I think Daniel just tweeted about this. You should follow Daniel, by the way. He's, there we go. Yes. So you can get a slices... Oh, get a slices underlying array pointer without unsafe. Yeah, so you can convert a slice into a pointer to 4 integers or something. That'd be nice. Yeah, so... In the meantime, we have to... something kind of silly. So B4 through 8. H router ID equals... So we have to copy into it. So copy into a slice from B4 through 8. Okay. Yeah, so now you can see router ID equals 192.168.1.1. That's the B4 address of my router primarily. So that seems like probably a good change to make the router IDs like this. The area ID is... Aren't areas also interpreted with the dot syntax usually? The IPv4 syntax? So maybe this should just be like OSPF ID or something, right? So area ID... Yeah, 00... Yeah. I wonder... I guess it's probably just like legacy v4... Oops, legacy v4 stuff. So I guess this would be, yeah, like OSPF ID or something. Like... And I can just use this ID value. But I could also return, so func ID uint32. Maybe if the caller cares about that. Although I guess they could just get it themselves, but does it matter? Like, is this a thing people need? I mean, I guess I'll just leave it alone for now. We can always add a helper method or something, but I'm going to swap out all the IDs with... Are interface IDs like that too? Hang on. Interface ID. I could have sworn I had a... Oh, we're looking at OSPFv2, aren't we? Yeah. We want to look at OSPFv3. That would be here. Interface ID. 32-bit number. Number. Nothing about how this is displayed, but it would seem that the router ID... remain at the IPv4 size of 32 bits. Router ID of all zeros, and then the area ID. I'm pretty sure you can identify the area with it as well. Area ID of 0. Okay, so this specifically only uses that for the router IDs. Huh. For v3. If there are any networking people here, would it be weird to have the area ID be this dotted decimal syntax as well? I'm honestly not sure. So I suppose for now we'll move on. The interface ID, I think we'll leave it alone. No. Okay. This will be an ID, this will be an ID, and then the neighbor ID is also going to be a pointer to an ID, so optional. Cool. But the interface ID doesn't seem like people use the dotted syntax, so I will leave that alone for now. So these turn into Tech Workbench. Thank you for the follow. I appreciate that. These turn into copies of 12 through 16 into the designated router ID. Slicing it, of course. And this turns into a copy as well. Slicing into that, 16 through 20. And then this becomes also a copy. So we allocate it first. So H neighbor ID equals the pointer to an ID of... So I allocate it. And then I copy into it. So H neighbor ID pointer B2324, right? Is this the, yeah, I have to dereference before I slice, right? Yeah. Okay, so this should make it so that way things display in a little more of a typical OSPF kind of way now. Let's see here. Cannot use 136. I must have missed one. Yes, I did. The area as well, so 8 through 12. Router ID and area ID. Okay. There we go. Okay. So router ID, that's the area 0. So all that. Now we have the IP addresses as well for example, the designated router, the backup designated router, and then the neighbor. So the neighbor, the neighbor it is talking to is seeing my router has established this server as its neighbor. So that's its neighbor ID right there within that packet. Cool. Looks pretty good. Hey, how's it going? Long time. Yeah, I've been streaming fairly regularly again, but yeah, nice to see you. Thanks for stopping by. Appreciate it. I'm trying to do like at least like once a week if I can, especially because I don't have a lot of plans on the weekends at the moment, just COVID and everything, you know. So yeah, we're getting somewhere with this. You miss ghost streams. Yeah, heck yeah. I mean, I enjoy ghost streams too, so I'll keep doing them, you know. I think I'm gonna go get some more water and stuff and run to the restroom, so I'll be back in a sec. Okay, we are back. You know what's kind of funny is when I'm putting stuff up on YouTube and I'm like editing out the breaks and stuff, I have to like hear myself right before and after every break, and I tend to say this pretty much the same things. Like every time I'm starting stream or ending stream or taking a break, it's always like, and we're back. Or hey, how's it going? Pretty silly. You've been busy with school. You're also happy you joined a team that now uses Go. Nice. Yeah, Go is great. It's a good language for sure. So glad to hear you're doing well. That's what entertainers do, catchphrases, yeah. I'm also just a pretty predictable person. If you're around me for any period of time, it's not hard to guess what I'm gonna do or what I'm gonna say. You know. I wonder if, let's see here. So we got the hellos now. I feel like we might want to start writing tests even. Like maybe, I don't know. Might not be a bad idea. Might not be the worst idea. I just wonder if there's anything that I really... Source, dest, interface, MTU, hop limit, traffic class. I'm just trying to think here if there is anything we want to do with regards to, let's see here. This is optional. So maybe I make this part of the struct, maybe I don't. I don't know. But I guess it would have to be part of the struct if we're going to marshal it back to binary later on. If we add binary marshaling, we could do really funny stuff like make the OSPF state machine mad by sending random hellos. That'd be pretty funny, right? Yeah, this is looking... Oh yeah, options. I want to figure out the options too. That's a bit mask of some sort. Not a bit mask, bit flags. Here we go. Options. Are the options always the same? LSA options. Let's see here. We are looking at the right RFC. Yeah, we are. I had to close the V2 RFC a little bit ago. There's a diagram in here I'm looking for. Where is it? I guess I should look at the table of contents, huh? Let's see. The options field. There we go. So the way I did this with my neighbor discovery library in the past is I broke out all the options into like Boolean flags, but I'm not sure I like that. Maybe it's like bit flags aren't the most friendly, but at the same time, like I don't know. I wonder what the correct way to do this is, you know? So I think probably what I'll do is I'll do type options. And then we'll have more options bits as well. So V6 bit, E bit, X bit, and RDC. Okay, so V6 bit options equals. Oh. Yeah, I guess that would be 0x0. Be a lot of zeros and then a 1, right? If this were uint32. Suppose this is where I write, like, you know, I write bit shifts, right? So the E bit options equals, suppose I could write these in hex. 2, 4, 8, N bit options equals 8. 1, 2, 4, 8, 16. So F, right? R bit options equals 0xF. Yeah? Yeah. Yes? Yeah. That would be the next bit. Yeah. It's really funny. My mind doesn't work very well with hex sometimes. I just, I tend to, like, not... I don't know. We're going to do like this so it's more obvious. R bit, and then the DC bit. 1, 0. Like that. I think that's correct. And then the X bit is X bit options equals 0x. This won't be exported though. Glory to binary. Yeah, that's a good, yeah, binary literals. That's a good point. I could do that, couldn't I? But then it's, well, I guess it's not that much work, right? So 0b, 0, 1. 0b, 1, 0. I could do this, couldn't I? Is this actually an appropriate use case for binary literals? It might be. Like, it actually might be. I mean... 0b, 0, 1, 0, 0. Right? I mean, I'm actually... This is a legitimate reason to use them. Uh, 1, 2, 4. Depends if you ask someone who likes hex or not, yeah. Since some of these are non-contiguous, 1, 2, 4, 8, 16. So I guess I have to have it like this, right? I don't know how much I like that. I mean, I guess it's fine. Ooh, excuse me. I guess it's fine, but I don't know how much I like it. I guess we'll tolerate it for now, but isn't that just 1 shift N? Yes, it is. So I suppose I could just write it that way, huh? I don't really want to do the iota thing though, but 1 shift 0. Yeah, we'll do it that way. Yeah, I think I like that. I think I like this option the most so far. It's kind of funny, you know, Go gives you these different options for like writing this sort of stuff now, and it's just it's fun, but it works. We make it work. I guess I'll just make this an int because it's a uint24, so it's a weird size and stuff anyway. So Although I guess if we constrain the size, then it's smaller struct, which is probably good. Yeah. Okay. And then we can actually steal the code from did I put it in ETH tool too? Yeah, I think I actually did. We can steal the code from ETH tool that does the fancy logic with the source github.com md layer ETH tool. The fancy spit out strings logic. So we're actually gonna want to add options as well to the stringer, and then we call the string method. Where is it? Where is it? This one. Yeah, it's the same sort of logic here even. Options. So the names are. I need to pull up the RFC again. And then those are reserved for the migration of OSPFv3 protocol extensions. Star, 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 star. Okay. Of a options bit mask. Cool. So this should actually give us nice output now too. I keep going to the wrong window. There we go. Should be actually be quite nice now that we see this. All right. Where's those hellos? There we go. Yeah, V6ER0x100. Did I miss one? Really? I missed one? How? Is Bird sending something? Let's go look at the Wireshark again, I guess. AF. Oh, you know what? I'm guessing Bird is using a newer version of the protocol, or newer updated to the protocol that the RFC does not have, so AF bit. ATLAF. So, options. So, we need to look at the updated OSPFv3 options. OSPFv3 options. Reserved, and then AF. Okay. Options equals 1 to the 8th. L bit options equals 1 to the 9th. And then the AT bit options equals 1 to the 10th. Okay. Now that ought to do it. There we go. V6ERAF. Me, IRL, RN, AF. Right? Good stuff, good stuff. We are making progress. My buddy's playing Age of Empires, and I told him to stream on Twitch instead of on Discord. He doesn't think his computer can do it. Yeah, it's probably true. Yeah, this is looking pretty good so far. So let's see. What else do I want to do? I do want to sort these flags. It's gonna drive me crazy otherwise. Um, Such a silly thing, but I want to put them in order, make it nice. Anyway. I wonder if I could just turn on all the flags, or if that would invalid. I guess it might. If I just do this, what happens? You know? Cannot use... Does that work? Should. There we go. Yep, just turn on all the flags. Cool. You were looking at the deep fucking values old post on Wall Street Bets, and he mentions Michael J. Burry predicting today on 2019 article, Christian Bale from The Big Short movie. What a man. Yeah. That whole thing is so crazy. It's I've got some GME. It's such a silly thing. It's like you can't help but just like enjoy the spectacle, you know. I think I'm gonna need to make this a little bit configurable as far as like join like the designated routers group and such. This pointer is so ugly, like having to do optional fields this way, but I feel like it really is the best option or the best way for us to do it, you know. This is letter to the investors board. Interesting. Type packet type. I guess I could do this like I could call this like hello packet instead. So if I do like hello temp, rename, so hello packet, 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 right? And then we regenerate these strings. Would it make sense to split into two types, hello and hello scene? Yeah, that's what I was debating as well, since you mentioned that earlier. I guess the only thing the thing I'm waffling about here is that since the RFC, hang on a sec. Hello scene. It's not mentioned anywhere in the RFC, so like I feel like OSPFv3 hello scene. I see what you mean. I think that like the pointer is probably okay, or what else? Something else I was thinking about doing is making it so that like I make it so that like neighbor ID is like a func like an optional function on here or something, or you could also like append a neighbor ID like it's an unexported field, because the pointer is just kind of awkward. But I haven't decided for sure yet. I think for now I'm gonna leave it alone, but it's definitely something to consider. So I guess I'll note that down. This is no hello. Consider breaking out hello scene, or using methods to more clearly differentiate whether or not neighbor is or should be set. I think with a good API, we can make this make sense, you know? So you got your hello. The neighbor ID is optional. Let's see here. So okay. We've already checked the bounds here. We checked the bounds there. Okay, so the unmarshalling is totally done. That constant really, I mean, I don't know. I guess I don't really need it anywhere else, like in the package yet, so I'll leave it here for now, but... Oops. May also be running simultaneously on this link. I guess I would assume it's probably fairly common for folks to deploy, for example, OSPFv2 and OSPFv3 simultaneously. Like, I guess my understanding is that although V3 can carry both, you can deploy V2 for your V4 infrastructure and then V3 for your V6 infrastructure. I know I personally only plan on deploying V3, which is why I'm doing just this, but... message.go. So the packet types and then the header and such is all going to move over into a new file. Package OSPF3. Or hello underscore message. So a pointer to a hello. I should get rid of that hello world snippet. I don't ever use that ever. So let's just get rid of it. But cancel, save. Okay, we moved a lot of this into its own file now. Let's start going through here. Don't save. Definitely don't save the generated file. Let's see here. So a packet type is the type of an OSPFv3 packet. Possible OSPFv3 packet types. And ID is a 4-byte identifier, typically used as a for router and or area IDs. OSPFv3 router and or area IDs in a dotted decimal IPv4 format. It's the length of an OSPFv3 header. A header is the header that accompanies all OSPFv3 packets. A message is an OSPFv3 message. And this could have like you could actually fetch the header as well, probably, if we wanted to. We could have it so that you do that, but it's not strictly necessary, I suppose, but hey, hello. That's right, I'm going to do my typical RFC thing, so... where was I going with this? Options, right here. So, options is a bit mask of OSPF v3 options as described in RFC 5340, Appendix A.2. Possible OSPF v3 options bits. Other declaration of string, not for options though. Oh, I did put it for options, didn't I? Yeah, that was a mistake. We're doing the option string manually because we're doing the bit masking stuff, which is or the yeah, the more fancy visual version. So I need to regenerate this really quick. Okay. Oops. Fixed. Actually, we'll put options up above, options and IDs up above. Right, so a hello is an OSPFv3 hello message as described. As described in the OSPFv3 header, packet header as described in RFC 5340. Because if you type out things with this syntax, it actually gives you nice links, which is why I do it. Appendix A.3.1. I don't actually know if that works for the described in appendix stuff. A32. Implements message. I don't know if we're going to want exported methods for this or not. Probably not, because we're going to be using the library to handle this for us, as well as attaching the header. So probably not. Probably not, but let's see here. Oh. Oh boy. Yeah, everybody's going crazy today about the all the stock stuff. My friends are mad because they were trying to buy more GameStop and all that stuff, and it's just it's a bit of a thing, you know. I mean, yes, done. Reminders. Opsline mini kegs. Don't do it. It's not worth it. Anyway. Yeah, these probably aren't meant for general use just because after the header, so we're gonna go ahead and do this. There's no real advantage to making these exported, probably. What are your thoughts on using IOTA for the options definition? I considered it, but the thing is that whenever I'm pulling values from like an RFC, I don't really trust IOTA. If I were defining my own, yeah, Dominic says exactly no IOTA for externally defined constants. That's the exact philosophy I follow as well. So I would use IOTA if these were my own constants. Like if I was doing type drink int const coffee drink IOTA beer tea, then this is totally fine. But for stuff defined in like an RFC, like these have to have this value always, I'd rather spell it out. That's just my personal preference. Thanks, makes sense. Yeah, no problem. No problem at all. Options is 24 bits. Cool. Yes, we got the hello stuff already done. Database description, interface MTU. Aha, this is what we were talking about earlier. Okay. IPv6 prefix. Oh, prefix options. Yeah, I want to start looking at this stuff. Actually, let's just take a look at Wireshark again really quick. I want to see what all was in here. So, for example, we get the database description. So, I think my router presumably has more interesting stuff. So the database description, interface MTU. Okay, so that's in there. So database description, out of band resync, init, more, master. Sequence number, LSA, type 1, router. The age, 14 seconds. Interesting. Flooding, only in the originating area. Link state ID, advertising router. Intra-area prefix. And then link. Oh, this is sending its database, and this database includes this other router as well. So both the routers being identified in here. I guess what I'm not sure about yet is how the prefixes are sent around. Link state, request, link state update. Because I've got a couple of prefixes configured, just dummy ones, and I was curious how they are propagated to these packets. Ah, here we go. Address prefix. Yeah. Address prefix, so the global, and then the unicast or unique local. Okay, so prefix options. Number of prefixes, link LSA. FD90, yeah, so the link LSA contains like the prefixes. Okay. So many bits. I feel like, decoding the packets and stuff is definitely the easy thing here. Like, building out, like, something that can understand the state machine is going to be much harder. But I think it could be, interesting, perhaps. So I will need to do a lot more reading, though. Intra-area prefix LSA. I need to read about all these different, like, LSA types. And just understand better. LS acknowledge. And the stuff you see in here is just the your gateway or your OSPF protocol number, the hop limit, the source address to send it. The destination is for example, the what do you call it? The multicast group. So this is being sent to all of the SPF routers. Nothing in here is designated routers only so far. Yeah, I guess at this point we should probably just keep working on this a little bit and like probably write out some tests and stuff. And then maybe consider like just committing what we have so far because we've already written a fair amount. Let's see here. So multicast groups used by OSPFv3. A con can send and receive OSPFv3 messages which implement the message interface. Dial creates a con using the specified network interface. IP protocol number 89 is OSPF. Return all possible control flags to the caller. Control message information to the caller so they can make more informed choices. So this is where I'm not sure. So join the appropriate multicast groups. This is where I'm not sure. You probably don't want to join the designated routers multicast group by default. Like, we're doing it because we're snooping all the traffic, but we probably don't want, let's see here. So to do MD layer, probably something you'd want to do here is like have some kind of like state machine transition type thing that fits together, and then you would do that, and then that would join like the appropriate multicast groups. It depends on the configuration. Okay. Yes, this would be either a configurable make joining all D routers either configurable or go through some sort of OSPF state machine before joining this group. Because we want to be like RFC compliant, but right now the code I'm writing is just kind of like YOLO out there, you know? So the groups for the connection is going to be both of them for now. Oops. And then you're going to leave any groups that you joined on the way out. So B groups. C groups. Read from reads a single OSPFv3 message and returns its data. Normally, Ethernet interfaces default to a broadcast multi-access, so it will do DR, BDR, right? So if it's a peer-to-peer link, you need to explicitly configure that. Interesting. Okay. If it's a peer-to-peer, point-to-point. If it's a point-to-point link, why would you need a designated router? I guess since there are only 2 routers in the topology. Well, is that just so that one can? If I understand correctly, like the way they issue like the link state updates and stuff, like the designated router is in charge of making sure it doesn't like or that's the only one that can flood updates to the other one. You wouldn't, huh? Okay. This is when you don't join DR BDR. Interesting. So actually, what we could do. So we could actually look at the flags of the interface. Let's see here. So type flags. So if it's point to point, we can skip joining that group, huh? Like, would you say that's a correct assumption? I mean, that seems reasonable to me. So we can check for up, broadcast, loopback, point to point, or multicast. So I think probably checking that would be reasonable. Cool. Note that point to point links don't have use DR, BDR, so skip joining that group. Sweet. If the interface flags, flag point to point is set, or if it's not set, we join designated routers. Cool. Thank you. And can skip joining that group. Yeah, thanks for the information. I appreciate that. And returns a message along with its associated IPv6 control message and source address. Read from will block until a timeout occurs or a valid OSPFv3 message is read. So we're going to need to expose a way to set deadlines as well. So ccon set read deadline. Ooh, excuse me. Time. Set read deadline sets the read deadline associated with the con. Got to drop. It's getting pretty late in UTCZ. I really enjoyed this. We'll watch the rest tomorrow. Hey, thanks for stopping by. I appreciate it. And thank you for the information. Yeah, I suspect I'm not going to go a whole lot longer tonight because it's a weeknight. But yeah, thanks for stopping by. We'll probably be streaming again on Saturday. So Saturday, probably afternoon U.S. Eastern time. So probably evening for you. But hey, thanks for stopping by. I appreciate it. Now that we've By the way, are you considering forming a Discord? Yeah, I've actually thought about that. I have a personal Discord I use for like friends and stuff, but I could potentially make a stream Discord as well. Or Gophers networking. Yeah, actually, I think probably the Gophers Slack networking channel would be enough. I would say that's generally where I would recommend folks hang out. So if you're not in there, definitely that's a great place to be. And what is it? Exclamation point go. There's a link where you for the invite and everything too. Would recommend. The header. You can identify the rest of the payload. As a known message type. You do MD layer. Implement more messages. Unmarshal methods assume the header has already been processed, so just pass the rest of the payload. Spotify's getting weird tonight. Writing test logic for this is going to be a bit of a pain. It's something we're going to have to do at some point, but I suppose I could make this take a context too. But if I make it take a context, then we have to break the connection by setting the deadline ourselves, and I don't know. I don't know. I don't know. Closes the cons underlying IPv6 network connection. Underlying network connection. Cool. That's right. We got to specify the groups as well. So groups, right. Assume a mess. Well, let's see here. So yeah, since this allocates for us, yeah, I guess the MTU is reasonable. So let's see here. Pretty good so far. Yeah, let's write some tests for this, and then probably we'll call that around 2 hours. We'll probably call that a stream after we write some tests. Seems like a good thing to do. Started dumping some traffic. We can tell that things seem to work, so we're getting there. Having a good time with this, though. We'll definitely continue on Saturday, if nothing else. So that'll be fun. What was I just saying? We need to write tests. Yes. Yes. Okay. All I got is her for today. Get the old watch loop started and start writing some tests. So, message test echo. OSPF3 test. Well, my friend wants me to come watch him play Age of Empires. It's actually pretty entertaining. Like, I'm not big on playing myself, but watching my friend play Age of Empires ranked matches is pretty funny because he gets pretty mad. So it's a good time. I guess this is where I probably make a parse message helper like I have with my other library too. Age of Empires 2 Definitive, the one that just came out like last year or something. It's pretty cool. I know like the DLC just came out for it too. Stream my stream on your stream, MD Layer. I'm not opening up Discord on Twitch. I don't trust my friends to not say really bad things. You know. They sound like fun friends. Yeah, they are. They're nice, but yeah, it's a thing, you know. For the time being, I guess we'll test, you know, within the scope of the. So let's see here. So test hello on Marshall, right? So given some input, byte slice, produce either a hello or an error. So probably do this pattern. So failed to unmarshal. So I have a little helper here that I write. So var h hello if error colon equals h unmarshal bytes. People aren't real friends if they couldn't get you canceled on Twitter. Yeah, true. Very true. Diff T. It's so annoying. You want the hello message. You got this unexpected hello, right? Yeah, I've got a snippet that generates this for me. So either, you know, failed to do this or expected an error but not occurred, or it prints out the error. So simple little stuff I tend to use a lot. So empty. Not enough bytes for hello. Yep. Header only. So, or no, OSPFv3. 02, what's the length of a header? 16 bytes? Yeah. Append like so. Missing the comma. Oh, like that. Like that. There we go. There we go. Cannot use type 0 int. Bytes repeat takes. Oh, byte slice. I see. My high school friends are still playing AoE 2 once in a week. Nice. Even though everyone's on a different country. Sweden, Netherlands, Italy, Turkey, and one from the US. It's an addiction for some millennials. Yeah. I mean, it's an awesome game. I actually really enjoy watching it. It's just that it tends to stress me the fuck out to play it. Like, I think it's super cool, but it's just not for me, you know? Oh, shoot. We're not even doing the header parsing. We're testing the... Yeah, we need to test the... We need to put the header parsing in there, too. Oh, I guess we're doing test parse message, something like that. So parse message. Parse message. B up through N. Assume invalid OSPFv3 data can keep reading. Something like that. And then we have the parse message constructor, which is the entry point for all of this stuff. Func parse message, B array of bytes. Message, error. If L colon equals len B, L is less than header len. No iterator pattern on this? Yeah, you know, I talked about it earlier and I considered doing it for these, like, you know, uint 8, uint 8, uint 16, uint 16. I actually really did think about it, but we're not going to do that today. It's not necessary for now. I'll format error F, OSPF3, invalid, unrecognized, OSPF version. Since you learned about it 1 week ago, you want to use it everywhere. Yeah, I understand how that goes. I do like that pattern a lot, and I did think about using it in this code, but it's just not necessary today. We'll get there. Error F, OSPF3. Unhandled, message type, H type. Message type. Parsing not implemented for message type. Yeah. Undefined N on line 112, right? L. Okay. This is going to be a test parse message, so M error : equals parse message, right? Unexpected message. We test for TT M versus M. Unrecognized OSPF version. Okay, there we go. We're getting there. Okay, now we get the header. Now we have an unhandled message type. So unknown message type. Parse not implemented for type 255. Yep, that's correct. And then we're going to have hello. This will be a short hello first. So let's see here. So append, bytes, repeat. Oh, shoot. I guess we have to have some sort of header here that's valid. And the packet length. Oh, I wonder if I should probably be honoring this, huh? Let's see here. More difficult. That's the wrong window. More difficult than anticipated. Oh yeah, I got Slack over there, or Discord. Let's see here. What's the iterator patterning go? I think it was the thing we were talking about, like on my blog and stuff like that, or like the netlink attributes pattern and stuff like that. It's just something I tend to use a lot. So packet length. The length of the entire OSPF packet in bytes, including the standard OSPF packet header. Yeah, I should honor that, shouldn't I? I should probably check it. Yeah. It's just a nice pattern I like to use when it comes to like dealing with byte streams and stuff. Found the article, thanks. Yeah, nice. And it's just something that keeps coming up, so I keep talking about it with folks and stuff. 03. Hello is type 1. Hello packet. I guess this is probably where I should start writing out the damn byte dumps, huh? Instead of doing this append stuff. Cannot use packet type. Isn't that UNT anyway? There we go. Checksum. Probably look at that too. Select packet length and checksum. So we have the version, the type, the packet length, the checksum, the instance ID, the router ID. So for example, 192.168.1.1, or no, I'll do 192.0.2.1. Oh, you see, yeah, it's just a pattern I like to use, you know. The area ID, and then the rest is the hello packet. So I don't know if that's for hello packet. Yep. OSPFv3, hello. Packet length, checksum, instance ID. Actually, I suppose this is one of the few cases where I kind of like comments on the same line as code because they line up really nice. I tend to not like this very much, but in this particular case, it'll actually be a lot nicer because I can do this, and it will get formatted like that, which is, why is that not formatting? That's weird. I would expect that to do this, right? What's the deal with that? Huh. Anyway, it's okay, I guess. Router ID, area ID. Is that formatting? How strange. Yeah, I don't like that as much, but it's okay, I guess. Area. Yep. And then we have the message is now a hello. With a header that contains a bunch of stuff. Hello packet, length 0, checksum 0, instance ID. It's going to be 1. Did that say UN8? Oh, I read that wrong, didn't I? Hang on a sec. Instance ID. Oh, instance ID is just 1. And then router ID. Reserved. There we go. That's a little better. Why is that still formatting all goofy? I feel like that should be lined up, right? I don't understand why that's not actually, but... yeah, so I also messed this up here, right? Yeah, 0, 1. Yeah. Anyway. Checksum, instance ID, reserved, router ID, area ID. Area 0. Actually, the 0 value is fine. And then inside the hello, I need things like the interface ID and such. So we're going down to the next type now. So the interface ID. Header. Now we have the hello bytes. So the interface ID is 4 bytes. The router priority is 1 byte. Interface ID, router priority 1, I guess. Options 24 bits. So I guess we'll set just a couple of the low bits here. So v6 bit with I forget what the options even mean. We'll just set the v6 bit for now. It's fine. We'll OR it with another one too, just for fun. Does this need an explicit type conversion? I guess it does, huh? Options. Okay. Options, hello interval is a, yeah, so let's see here. 5 seconds, and that interval will be 10 seconds, sure. Hello interval, router dead interval, and then designated router ID. Backup designated router ID. The neighbor ID is optional, right? So Neighbor ID. Yep, there we go. It's not really a pattern in conventional software patterns, but generally don't even like the naming. Yeah, I mean, I guess if I say iterator pattern, I tend to just use it just because it's convenient to say that. But yeah, I understand what you mean too. Router priority 1, right? Is that what I said? Options, v6 bit, e bit. Everything is a pattern. Yeah, true. Uh, 4 through 8, 8 through 12, 12 through 14. Hang on a sec. So do I have an off by one here? I think I might, but let's fix the rest first, I guess. So options, hello interval 5 seconds, router dead 10 seconds. Yeah, I think I got this wrong, didn't I? With a good PR and at a publisher, you can make your own software pattern too. Yeah, exactly. I got this wrong somehow. Parse message, header, version 3. Starting where the header ends, 16. This is incorrect, isn't it? Yeah? Is that right? -1? No. That should be correct, I would think, but area 0, checksum 0, instance ID 1. I think I'm just reading my tests wrong. Version type, packet length, router ID, area ID, checksum, instance ID. You want 1, you got 0. You want, so the area is wrong. Yeah, I've got some logic here that's slightly wrong. The version, the type, the packet length, and then the router ID. Oh shit. Yeah, I'm dumb. Packet length, and then the router ID, and then the area ID. Yeah, I was writing them out in the order that they appeared in the document over here. Hello, packet length, area, router, checksum. There we go. Yeah, that fixes it. Yes. Anyway, the designated router and the backup. And finally, you have the neighbor. Ta-da! There we go. It works. We have test coverage. Cool. I wonder why this is formatting so funny. That doesn't seem quite right. It seems like it should be, I would expect it to be like all pushed out nice like this, but I have no idea. I don't know. Is it because of this comment attached up here? No, it's not. I guess it's okay. Router priority. Yep. All right. We done good. This is probably a good place to get our first commit in, I would say. Started working on a library. We wrote some stuff. You found it. It's the gem Brad Fitzpatrick on software patterns. I've checked it out later. I can imagine what he says. Parse message versus an OSPFv3 message. Header and trailing message from bytes. We're going to need to copy over all the license and header and everything else. The license and the GitHub actions and all that stuff too. Jean L. Persia, or Jean L. Persia, thank you for the follow. I appreciate that. So this is the point where we copy all the good old markdown files and stuff from the other repos. Like, for example, ETH tool, because we just created that recently. So source MD layer ETH tool, all the markdown files, and then the GitHub folder as well. Stack analysis go 115, tests on Ubuntu and Mac. We don't really care. We don't care about Mac on this. We'll just do Ubuntu. It's fine. License 2021, Matt Layer, MIT, README, ETH tool, OSPF3. Okay. The dot comment is this. OSPF3 implements OSPFv3 as described in RFC 50. Yeah. MIT licensed. We actually have the RFC already open, don't we? It's in one of these tabs. There we go. RFC 5340. Beauty. Okay. I think we're done, right? I think we're done for the day. Need to get rid of I need to get rid of spew in my dependencies. Ugh. So let's see here. Log printf. Something like that is fine. I don't want the go spew stuff in my go mod. It's just a pain. Why are my dependencies not upgraded? Go mod tidy. Build. All the Go files, all the readmes, the go.star, not the pcap, the GitHub folder, git ID personal, OSPF3 initial commit, git remote. I need to go make the GitHub repository now, don't I? Okay. So, new. Love creating a new repo. Always fun, huh? OSPF3. OSPFv3, described in RFC 5340. MIT license, single space. Public. And then we git remote add origin GitHub MD layer OSPF3 git push -u origin head. Okay. That should all come up. And we got us a Git repo. Sick. We done good. Let's see here. So networking, Golang, OSPF, IPv6. We'll do Go as well. There we go. Ship it. The test should pass. Actually, I didn't run static check. Oops. It's fine. I write good code, so it's fine. All right, gang. Yeah, we done good. I think we are probably going to stop here for the day. I think this has been it's been a good stream, a couple hours here. So I'll be back on Saturday. Is there anybody? Yeah, nobody tech related anyway. So all right, this has been fun. We'll be back on Saturday. So hey, thank you all for hanging out. I appreciate it, and I will see you all later. Bye now.